Hello and welcome back to Azure Terraformer. I just gave a talk at the Columbus, Ohio DevOps group, which is a recently reinvigorated group organized by my partner in crime at the Azure Meetup, Drake Lundstrom, which, as you might imagine, is pretty tangential to a lot of the stuff that I'm involved in right here on this channel, as well as with the HashiCorp user group of Columbus, Ohio, and the Azure Meetup. So definitely want to support this group and would love to see a lot more talks. And a couple of great talk ideas came up in the cool down period at the end of this talk. We were just chit chatting and doing Q&A. So definitely hang out for the Q&A at the end. It's a pretty fun group, pretty low key, pretty laid back. But I'll be talking about Gitflow, CI/CD, GitHub Actions, and doing a live demo. So hope you enjoy the talk. Let me know what you think in the comments below. Without further ado, let's get started.
Talk about it, which is the goal. Okay, wonderful. So hi everybody. He told you a little bit about me, but I'm going to be talking. I don't know, what was the first talk for the DevOps Meet? I'm not retreading ground. Was it GitHub Actions? No. Okay. Oh, okay, good. All right. So I wasn't sure. I couldn't make that last one. For reasons, but I'm glad this is a relatively new topic. Hopefully, it shouldn't be all new, right? But if you're new to this, hopefully, I have some new things to bring to the table as well. So we're going to be talking about implementing Gitflow and enabling CI/CD with GitHub Actions. So if those are interesting to you, this is me. I always look like I've got a super tan, when it comes up on a projector like this. I don't know what's going on there. It's like I just got back from Aruba. That's literally what I look like when I get back from Aruba or someplace sunny. But yeah, I work at Microsoft. I actually work on the Azure engineering team, focused on resiliency. So if things go bump in the night, I'm the one to blame. Just kidding. No, I'm actually trying to fix it. My team, we're trying to solve cross-cutting issues across the services. So that's what I do there. I am a HashiCorp ambassador just because I love Terraform and I have a lot of fun with it. And I lead with my buddy Drake there the Azure Meetup of Columbus. So if you do work on Azure, we are looking for speakers. So please, come share your knowledge, with the broader Columbus community. Would love to hear from you. Azure is a big word, right? So we talk about everything related to Azure and Azure tangential. We're trying not to be like a soft skills group. We're trying to be hard, technology skills. So anything within these few, it's a small tent. We have a very small tent, Azure. Not a lot going on. Any of these topics, if you have interest in those or stuff about those topics, we'd love to hear from you and to share with the broader community. I also organize the HashiCorp user group, or the HUG, which is kind of weird. That's officially what they call it. They call it the HUG, the HashiCorp user group. But it is kind of is this safe for work? Can we go to a place called a HUG? I don't know, but there's not a lot of hugging going on, as you can see. But we do talk a lot about DevOps, but through a kind of particular lens. We focus on HashiCorp tools, which does a lot of infrastructure lifecycle management, a lot of security stuff. Everybody, kind of brings different interests to the table. I don't actually know really anything about Vault or Boundary or Console. I learned a little bit about Console, from one of the speakers, but my interests are largely around infrastructure as code, with Terraform and Packer and stuff like that. But we try and get people to talk about lots of different things. Vault is who's heard of Vault? Okay, yeah, there you go. I mean, I've heard of it too. So we got something in common already. But I've never used it, but it seems like it's a pretty cool hybrid cloud secrets management tool. I use Key Vault personally, but that's me. But yeah, so if you're interested in that, we've been Chris right there has been presenting just recently about Proxmox, and I was so inspired by that. I like piggybacked off of what he did. I literally took his code and was like, all right, no, I don't want to use Fedora because I'm like a loser and I'm using Ubuntu. No offense if you're like me and like you aren't super opinionated about Linux distros, but like I converted what he did to use Ubuntu, and I set up a Minecraft server on my own Proxmox hypervisor at home so that my son and I can like go and punch trees together and stuff like that. It's a good time. And I gave that talk last week, and the HashiCorp user group, unlike the Azure Meetup, is a multi-cloud space. So if you rock AWS, the giant bookstore in the cloud, if you like the search engine people, you're welcome. If you like Big Blue or Oracle, I guess we'll let you in too, but like whatever. Anything goes, as long as you're using like one of those cool tools on there. It is, yeah, they are, they haven't closed the deal yet, but like IBM is going to acquire HashiCorp for about $6.4 billion. So yeah, a lot of money, a lot of green or blue-green. This is the DevOps group, so I can make these jokes, okay? And you guys actually get them, which is wonderful. Drake also mentioned that I wrote a book. Yay! 574 pages. So if you're into a little light reading, light up that gas fireplace and cozy up with a little, blanket or DeVoe or whatever, and go to town. My book, I try and be an equal opportunity terraformer, unlike on my YouTube channel where I just do Azure Terraform. But my book, I wanted to meet the reader where they are. So whatever cloud platform you choose, to plant your, cloud solution, like I meet you there. So I have equal coverage to AWS, Azure, and Google Cloud. A lot of books, it's like they say that, but then it's like 90% big, bookstore in the cloud, and then like 8% Azure, and then 2% Google Cloud. And it's like, but literally, I give 3 chapters to AWS on 3 cloud paradigms, virtual machines, containers, Docker and Kubernetes, and then serverless. So there's a chapter for AWS on all 3 of those paradigms. There's a chapter for Azure on all 3 of those paradigms. And there's a chapter on Google Cloud for all 3 of those paradigms. And there's an end-to-end solution. So it's literally 3 by 3, which is why it's 574 pages. So
what you're saying is we can read 1/3 of it.
Exactly. You know what?
I'm not going to say which.
And it is a bit. I used to love those like choose your own adventure books when I was a kid. Like go to page 114, go to page 59, whatever. So absolutely, and I even mentioned that in my book. I'm like, I could totally understand it if you skip the chapters on AWS. Just kidding. But like, yeah, if you don't want to rock Azure, you don't want to rock Google, whatever's your flavor, you can read those 3 chapters and just stick to it. I do reference like, hey, you might want to go check out this section because it's common across both. But yeah, so that's been consuming my life for the last year. So what are we going to talk about today? We're going to talk about source control, Git. We're going to talk about Gitflow, what, how, why, CI/CD, GitHub Actions, then I'm going to try and do a live demo. Let's hope that works out. Okay. So Git, source control. I mean, we could just like end the talk right here. That's all you need, right? You just need source control, and then you're done, right? It's just it's over. Like you just start committing everywhere. Like everybody commits to the main branch. That's how it works, right? Who does that? Who devs like that? You're just oh. I committed to main today, so I can't throw. What is it? He who cast the first stone, something. But no, yeah. Like I get it. But yeah, there's definitely pros and cons. Like you probably don't want to be committing to main, especially if you're working on a team. So what do we do? We've implemented something called Gitflow, and it's not like a technology or anything really. It's more of like just a shared convention of how to use Git, and mostly to how to use Git as a team. And that's really where Gitflow shines, is like being able to implement these team-based workflows. And it's all about basically how you branch and when and how you merge and what branches you merge into. And then what happens when those certain events take place. And that's really what Gitflow is all about. There's, lots and lots, there's many, many different forms of Gitflow. It's kind of like Agile, like you can kind of pick and choose and kind of customize it to how you guys work. There are, I'd say even more so than Agile, as I look at this like really nice Kanban board over here, it's like, wow, that's pretty. I think that even more so than Agile, there are probably more kind of stabilized canonical ways of doing Gitflow. Like there's GitHub Flow. I think just when people think of Gitflow in general, they think of, main and develop and feature, right? That's like the main thing. But then you also have like release branches and hotfix branches that are variations that some people use. But when you implement the team workflow, it's the first thing that you get right off the bat, is this ability to just say, okay, before we merge into this branch that we have ordained as either like production or, some level of quality that we all agree that this code is going to meet before it gets in there, we agree that we're going to have somebody look at it. That's like the baseline thing that you could do. You have a code review. And it's a great opportunity to get, and again, it's like part of team workflow, get somebody else to look at it. It doesn't have to be your boss or their boss. It could just be a peer review, right? Somebody else who's sane, which is hard to find these days, to kind of bounce your code off of to make sure it doesn't smell funny, it's not going to break anything, things like that. That's kind of the baseline. But now that we have that, it's like, well, okay, I want to, I could spend, I'd have to clone your repo and like make sure it all works. So we introduced this thing called continuous integration, which basically says, okay, we're going to try and take some of the burden off of humans' eyeballs to try and figure out if your code is terrible. And so we basically add some extra things. So what else happens as part of this CI process? Well, back in my day, okay, it was not a foregone conclusion that your code actually compiled. And I think my generation, maybe I'm taking credit for this too much, but I think my generation invented the line, it works on my machine. Who said that before? Yeah. Okay, you're lying. I know you guys have said that before. It works on my machine, whatever, See, when I was coming up as a developer, the people that were saying back in my day, their stories were all involved these punch cards, and they're like, back in my day, we had to manually put the punch cards in the system. I get to say it works on my machine. That's what I get to do. Dating myself. But, with the first thing when we started implementing continuous integration back in the late 90s, early 2000s, was just does this thing compile? Can it, does it link, right? Is it talk about setting the bar low, right? From a quality standards, but, back in my day, it was a common thing. People would push into the shared branch and it wouldn't even compile. So
Say it like it's not still happening.
I'm sure it still happens, but this it's because you're not doing CI, right? And you're not protecting your main branch. We'll get to that later. But the whole idea about a continuous integration process is you have this third-party computer that runs these activities that basically check to make sure that your code meets a certain quality standard. The first quality standard is, does it compile? Does it build? Right? Then the next is and again, this is all taking effort off of the code reviewer, right? Because previously, I'd have to go pull your code, right? Compile it. Okay, it compiles, right? Then the next step is well, does your code suck? Is it terrible, right? Did you follow naming conventions? Does it have a method that has 32 string parameters, you know. These are all things I've seen, right, in code reviews that I've done in my career. And static code analysis, this one little item is like Baskin Robbins. There's like 32 flavors, right? Anywhere from naming conventions to detecting anti-patterns within a code base, security and vulnerabilities, code complexity analysis. It's one of my favorites because I can't stand looking at like methods that, you know, have 32 parameters or if blocks nested. If, you know, you see them on Twitter. Those like professional programmers that post these memes on Twitter where it's an if block that's like this deep. I don't know where it's probably their own code that they're posting, honestly. But yeah, so like static code analysis, these are things that we add to make sure that we don't have to have a human's eyeballs go look at those things. The next thing would be like tests. Okay, like your code. Do you have a question?
Yeah.
Yeah, go ahead.
Just like for static code analysis, I see a lot of stuff with linters and things for JavaScript. I don't see as many things for C#. Are there any that you'd recommend, especially in Azure DevOps world?
I don't know about linters for C#.
Anything that's static code analysis. I have a third of our pipelines didn't actually have a compile step.
Usually like with linters, because linting is a type of static code analyzer that just looks at really like white space. I mean, let's be real honest, right? There's certain languages that are very fickle when it comes to white space, like Go, YAML.
This is more of a is variable in use, like the standard like air checking.
Oh, yeah.
Or even like line length, because now you can Lint that does the full static code analysis.
Gotcha.
JavaScript.
Yeah.
I'm in C#.
So the biggest one that I've used that I know is like SonarQube, right? And there's SaaS offerings for that. It's worth its weight in gold. It's really good. But on .NET, there's another one that may not be as well known. It's called NDepend, and I'm not talking about grandma's like, you know, senior moment, you know, insurance policy. It literally is called NDepend. I think it's made by a German guy, so they, you know, it's probably like a brand, you know, that doesn't translate, you know, lost in translation. What's that?
Just trolling everybody.
Maybe, yeah. All these Americans need NDepends, you know. But NDepend is really cool because I think it was like the first static code analyzer that actually lets you use like basically code QL, right? You used LINQ to query the code. So you could create your own custom rules that were just incredible for detecting like weird situations that a standard like regex static code analyzer isn't going to pick up. But it kind of costs a lot of money. It's like $400 or $600 or something like that. But I've convinced many employers to purchase NDepend for me. That would be my pick. Yeah, unit tests. So this is like, does your code compile? Is your code garbage, right? Unit testing is like, does your code actually work, right? Or did you jump through some hoops to kind of try and convince us that your code works? Is a more apt way to describe unit testing. It often is the case. But all of these are really about reducing how much time a code reviewer is spending eyeballing your code. So, you know, yeah, I've seen a lot of bad unit tests in my day, but, you know, if you're doing a code review, like, you just need to go look and see, do they have unit tests? Do they have a well-structured unit test? Like, do their assert statements make sense? Or is it written like, you know, like a Disney Star Wars show, you know? Stuff like that, you know? Just want to make it make sense, okay? Next, and the final step, and kind of the culmination of a continuous integration process is, you know, okay, we've passed all these quality gates. We want to package up our code into a deployable artifact, whatever that may be. That could be a Docker image. That could be a zip file, with a funny file extension like jar or war. It could just be a zip file, or it could be like a completely proprietary thing where you have to use some custom CLI tool and pass it in a folder path and it spits out whatever. Whatever you need to package into to target, the environment that you want to deploy to. Usually a CI process is going to output a package, a version package, right, that then gets dropped into some, version repository, which can be referenced later for the next step of the process, which, is the CD process. But probably the most important thing, and I kind of alluded to this earlier, was you don't commit to the main branch. And why? It's not just because that's taboo for no reason. It's like because you skip all this, these quality gates that make sure that get triggered, when those events in your process take place on the pull request, right? So if you don't protect your branch, people can kind of sidestep that process and, not have all these things that are going to make sure that you aren't going to break the build. Now, the continuous deployment process is the other part of CI/CD, and that's where, essentially, we're not going to be doing it on the pull request. It's okay. We have a good version working of the code. It's passed all the quality gates. It works. We're ready to deploy it. And the branch that you trigger this CD from could target a different environment. Back to like the different variations of Gitflow that you use, right? You might have multiple long-lived branches, right, that you do a pull request into. Maybe like you have a staging branch, or you have a test branch, right? And you merge into that, or you have a release branch, right? And you merge your pull request into that release branch, and that's going to deploy to that release staging environment, vNext environment versus actual prod, so that you can do whatever is next in your process. And so that, like, because we have these packages, right? Every time we complete a pull request, right? Developer 1, they submit their feature. It goes through this review process. It goes through quality gate. We have a new package issued. We're going to trigger a CD process. The next developer comes along. They implement their feature. They merge, with the previous developer's feature. It passes all the tests. It passes all the quality gates. We have a new deployment package, that we put it all into. And these things are going to get deployed to our environment, wherever that may be, right? Every single time. And again, that environment, is going to be largely dictated by the branch that you're on. So there's a bit of configuration management just from a Git standpoint to decide what branch should target which environments. And so what else can happen in this process? Well, first, and this has become more in vogue, when we've had more sophisticated tools for infrastructure as code, where we actually provision our environment in an immutable way, right? Like the first time we run this, we provision the environment. The next time we run it, we apply any updates to our configuration to bring that environment up to what we expect in that version, in that vNext version of our application. So if we add a new feature, that new feature might use some additional part, of the infrastructure, maybe a new cloud service, something like that. We're going to add that, we're going to provision that thing in the cloud, right? We're going to add the configuration in that environment, and then we're going to deploy our code into that newly updated environment. So the infrastructure configuration gets kind of updated in parallel, in lockstep, one might say, with the application code. Because there is a place where the application code, kind of where the body meets the soul, so to speak, in terms of the application code kind of has to know, like, where the things are in the infrastructure, for it to talk to. Whether it's a connection string, an endpoint, whatever. Even if you're not using like secrets, right? Like you're using something like managed identity or an IAM role. You still need like the endpoint that you're going to be targeting for that environment. So rather than like hard coding that can be fed in based on your infrastructure as code to the actual deployment process to push the code there. And then that next step is the deployment. Okay, so our environment's there. If it didn't exist entirely, it now exists. If it was an outdated version that needed some small update, that small update has been applied, and it's ready for us to deploy the new hotness. And then we perform that deployment. That deployment could be as simple as updating the AMI image name, right? Which will cause like the VMs to spin up. That could be updating Kubernetes manifest and doing kubectl apply and pushing that updated version out to your Kubernetes cluster. It could be anything, like whatever it takes to push that application to the host environment that it's going to be on would be a part of that process. You'll also have things where you might have to do Delta differentials if you're changing database schema and stuff like that, right? So these are things that you need to keep in mind as part of that deployment, those transformations that are necessary to keep that application up and running so that vNext is fully functional when it starts popping up on the different nodes that are out there. And then lastly, like you're gonna run some acceptance tests, right? And these are usually tied to health probes that are built into your application. Again, kind of a place where the body meets the soul, right? Where how do we know our application is actually ready for traffic? And not just like the bits are dropped, but like the process isn't running or it's returning 503s, right? So you should integrate that as part of this final check. And there's more sophisticated ways of doing this and less sophisticated ways of doing this. There's kind of canary deployments where you can ratchet up over time the percentage of traffic that gets pushed to the new nodes that are running the vNext version of your code. But you need to have a mechanism like a feedback loop where your release process knows, okay, the vNext has been released, even if it's 20/80 split. I know that the 20% is healthy, right, and it's accepting traffic and things are good. Then I can gradually increment that up to 100. That's a critical part of a continuous deployment process. A lot of people kind of forget that, and it's just like lay down the infrastructure, drop the bits. No, it's a lot more than that. And so now, like, we're getting into GitHub Actions, and GitHub Actions are really just like a pipelining tool, like Jenkins or Azure DevOps pipelines, that lets you facilitate these automations that you want to run. We went through several automations like in the CI process and in the CD process. These GitHub Actions is yet another kind of platform as a service or software as a service. It's a managed service that basically lets you configure general purpose automation, right? You can run bash scripts. They've got different actions that kind of encapsulate more sophisticated functionality, like if you different platforms for like .NET, or if you have different tools or linters. I think there's a GitHub action. I think it's called Super Linter. Has anybody heard of that one? It's a pretty cool one that basically it kind of I don't know if it automatically selects which linters, or it just loads all the linters that there are, and then it runs them, right? So there's a marketplace, as you would expect, and when I say marketplace, I mean most of these things are free, but it's more of like there's a place where people can publish relatively trusted actions. Like if you are a company like HashiCorp, right? They publish GitHub Actions for Terraform and Packer and all these things, so that it's not just like some guy with a dog on his profile picture or something like that. And what?
Never ever. There's
No.
nobody posting packages
No, nobody like that. So it's like, okay, I'm getting like the official tool from the official company that releases this thing, and I can use this, and I don't have to just roll everything from hand using Bash. But you can roll everything from hand using Bash if you wanted to. And so you basically can set up these GitHub Actions to trigger at key points within your Gitflow process. And the most common ones are on a pull request and they're on a merge, right, into particular branches. And so CI is going to get triggered on the pull request, and CD is most often going to be triggered on the merge. And of course, it's choose your own adventure. You can choose to add as many quality gates as you want to that pull request. So if you wanted to, I didn't put a slide in my deck for this, but this is one of my favorite things to do. If you want to spin up like an integration test environment, you can, and this is one of my favorite things to do with Terraform, you can spin up a dynamic environment, do a full CD process essentially to a dynamic environment, deploy your code to that dynamic environment, run a whole suite of integration tests, and then after you're done, destroy that environment, and decide if you're good to go. That's a whole nother level than just running unit tests, right? Because you actually know, like when the user hits this action, hits this button, the actual like expected response comes back. And so really it's up to you how much effort, how much engineering you want to put into these processes. So when we look at GitHub, let's take a look at GitHub Actions anatomy, like what's all involved there, right? I mean, the first thing is, the trigger. We've talked about that. On PR, commit, merge, there's actually dozens of different places where you can trigger GitHub Actions, in weird situations. If anybody has an interesting one that they've used, I'd love to hear about it. But
I mean, the one for me would be more variations of a merge, where it's specifically only if these files or these branches were changed, like only run your infrastructure if the Terraform files change.
Oh yeah, like file system based filters. Like if a file in this folder got changed, then do this. Yeah.
Branch-based filters. I mean, it's pretty basic, but it's nice that eventually you start paying a lot of money for GitHub Actions. It's like, no, I only want to run the Terraform when I've updated the Terraform in develop and not just on my local.
Yeah, it sounds like somebody's got to work on their bicep.
Wow.
Jeez.
Right.
Yeah. So yeah, I guess I was spelunking this earlier today, just like in prep for this. But like, there's triggers on like anytime somebody creates an issue. It's like, wow, okay. Somebody that's spent a lot of time in Azure DevOps, that doesn't exist in Azure DevOps that I'm aware of. But there's dozens of them. It's pretty wild. So I think there's a lot of potential to like really do lots of crazy things and have pretty sophisticated process going here. But I mean, like GitHub Actions follow kind of the similar structure that you see with other pipelining tools. There's a job, which is a collection of steps. I don't think it might even have stages as well. I can't remember. Maybe it's just jobs.
There's like workflows at the top level, maybe.
Is there workflows?
There's at least 2 levels in the file. I don't remember what.
I might be confusing Azure DevOps. Azure DevOps definitely has stages, jobs, and then like tasks. But I don't know. I'll have to go check that. If anybody's got the Google, or the ChatGPT, let me know. Jobs again, are like we were talking about with the CI process. It's a third party, right? So all this stuff is running on a fresh, VM or a fresh image, fresh Docker container. So specifying the agent is basically like, where do I want this job to run? And so out of the box, you can run on one of GitHub's servers, which run on Azure, by the way. Or you can be like, I want to provide a custom what do they call them? Agent runner, custom action runner. I think that's what they're called. And this could be an EC2 instance in my AWS account, or this could be a container app, if I don't want to spend, full, for a full VM or something like that.
Your local computer.
Maybe. I would think
You
so.
can run GitHub Actions off your local as long as it's Wi-Fi connected.
Yeah, and like all you need is like an agent, that like basically polls the mothership and says, "Hey, do you have any jobs for me? Like, I'm ready to rock and roll." So yeah, that could work too. Exactly. It's just a computer, running somewhere. You decide where you want it to run. If you don't want to think about it, you don't have to think about it. If you're in a high security environment, you're probably gonna have to think about it because you're not gonna run on a publicly internet connected agent, right? You're gonna have to be private network connected to your stuff. So you're gonna have to think about that. But if you're doing simple projects, you're committing to main anyway, so you just you just run on Ubuntu late. Why am I looking at you? I don't know. I'm sorry. But anyways, so jobs have steps, and steps essentially perform a custom, like a single action, and that single action could be run this huge bash script, really, right? But yeah, it's kind of up to you to design how you want your action to be structured. And then you can define dependencies between jobs and steps to make sure that, like, hey, I need to build the code and then I need to run the tests. Like, I can't run the tests before I build the code, that sort of thing. That makes sense. I can't deploy my application until the infrastructure has been provisioned, things like that. I can't, I don't know. I could keep going. Variables and secrets, these are ways that you can configure metadata about your repository to basically bring outside configuration or secrets into the GitHub Actions. To kind of, I usually use them just to either point the GitHub action in the right direction, or to provide methods to authenticate, right, via secrets. But now with OpenID Connect, like, you can set up GitHub Actions to kind of implicitly auth with managed identity on Azure or AWS, like an AWS IAM role as well. So I think secrets are going to be like less and less needed, which is pretty cool. And then another thing, I don't know how new this is, but like I feel like it's, I don't know, at least within the last couple of years, but you can set up environments where basically this is a way that you can encapsulate a collection of variables and secrets under the heading of this is dev, or this is test, or this is prod, so that you can kind of segment, the GitHub action to be like, okay, this is what you're going to go do, but you're going to do it for dev, and all you have to do is like point it at the right environment, and it'll pull the correct variables and secrets and rock and roll. So that's a pretty cool thing. And this is kind of what they look like in real life, right? So it's YAML based, and a lot of the things that I mentioned there have their own schema, jobs build, runs on, that's the agent, steps, and then you have to know YAML and stuff like that. And then, there's some common, syntax or vernacular for each step. But then when you use custom actions, they might have their own, predefined input variables that you have to go read the manual for. But if you're just using like bash scripts or something like that, the most common ones are going to be like, what working directory do you want to run the script in? What environment variables do you want to pipe in there? And then, what script, either an embedded script, with a bunch of pipes, or like a script file you want to execute that's within source code somewhere. So yeah, that's pretty much what it looks like. Any questions about that so far? Okay. So who's ready for a live demo? Yeah? Okay. So my wife, my ticket came, I pre-ordered one of these, and my ticket came up recently, but my wife was like, once she saw the thing, she was like, hell no. And I'm like, come on, please. They look amazing. What are you talking
Have
about?
you seen the big thing recently where there's a bunch of raccoons like damaging them because they can't pull them apart from dumpsters? They're trying to open it and get the food.
Oh my gosh, that's crazy. Oh yeah. These weirdos with dog pictures in their profile. Yeah. You never trust source code from those guys.
You're not sharing that screen if you're...
Oh, am I? Oh. So, I'm probably gonna just stick in the browser. I'm sorry, don't hate on me too badly, but I think we can look at this code pretty well from here. Here's an example, of where basically I'm like the trigger I'm using. I've set it up to be a manual trigger, mainly for demonstration purposes, right? But just imagine like you can trigger this. This would be your CD process, right? So you can trigger this on like merge into a particular branch. But you can see the trigger here. There's the special, this is really cryptic, honestly. Like it's like hidden in plain sight, but it's called workflow dispatch. Whatever, I'll show you what that actually translates to. But this will allow you to kind of pick from a list the environment, and that's going to drive the configuration that we use as part of this process. So you can see I've got a job that runs build. So this is going to build my .NET code, and it's going to do all the things related to that, and then it's going to publish a deployment package, which is just a zip file, and it's going to upload that as an artifact. So you can see there's probably .NET like official actions, but I'm just dropping into Bash and running .NET CLI commands. So choose your own adventure. If you feel more comfortable using kind of the, custom actions, go that way. Or if you just feel more comfortable using Bash, do this. But prior to Microsoft, I was in consulting for many, many years. And so I built many, many pipelines that do many, many things. And it turns out every customer just has their own opinion about what pipelining tool that they want to use, right? GitLab, Bitbucket, Azure DevOps, GitHub Actions, whatever. So, and a lot of those, every single one of those pipelining tools has their own marketplace, and they want you to use their crap, right? But the YAML that you use for that stuff doesn't translate to other platforms, usually. So I just got in the habit of just writing stuff in Bash, because then it's like portable, and for the use cases that I've got, like we're good to go, And then if a new CIO comes into that company and mandates we're moving off of Bitbucket, we're moving to GitLab or whatever, like they're not locked in and they can just move. But that's me. But you can see here I'm also running a deployment process, which basically is I'm referencing the environment. I'm using that input that I pulled from before, and I'm actually setting up Terraform, and I'm getting some outputs from Terraform that I'm going to use as part of my deployment process. You can see here I'm like grabbing basically the front end storage account. So this is deploying an ASP.NET, what do they call that? Blazor application, which is a framework that lets you create single page applications for, .NET or something. And basically it packages up as kind of like a WebAssembly. And so basically all I need to do is drop static files. And so my deployment process is just uploading using an Azure CLI command to this storage account that Terraform provisioned and configured for me to say, hey, here's the front-end web application for my stuff, right? That's it. And so if I go trigger this, any questions about this, by the way? Okay. So if I go trigger this, I go to Actions, do it on a new tab, I'll go to front end, and this is where, let me minimize this, it's kind of annoying. So this is where I can go run my workflow. This is that what is that? Workflow dispatch? Yeah. I don't know why they call it that. They could just call it run workflow or workflow manual trigger. I don't know. But it's pretty cool. Like it lets me pick from a pick list what my environments are. And where you set up these environments, you go to settings, and then right here you can see I've got these are the environments, right? So if I go into the demo environment, I've got some configuration set up here. Much of this is used for Terraform to kind of point it in the right direction. But also some of this is like what Azure subscription, what environment we're targeting. And then there's a secret as well, right? So I haven't fully configured to OpenID Connect. What's up?
Is it possible to set up like a library of shared secrets or shared variables that a bunch of different repos subscribe to, similar to Azure DevOps?
Yeah. You do that at the organization level. So actually, I did that for my Azure Terraformer organization. Let me show you that. So I've been developing some Terraform modules recently, and all of my Terraform modules, part of my process is it's actually a pretty neat GitHub action, but there's a code generator for Terraform module documentation. And rather than me running that like CLI command myself, I set up a GitHub action to execute that on a pull request and pre-commit that to my feature branch. So I don't have to run it at all. Like it generates the code and injects it into my feature branch as part of the process. So, but the way, and I can show you that here. So here's my Terraform docs, and see I'm using the pull request trigger. And basically I am running Terraform docs, GitHub Actions, and there's a parameter. So it's a custom action, and they have this feature. So I didn't do all this hard work myself. I'm standing on the shoulders of giants here, and they have this Boolean attribute that I set to true, and that as long as the identity that I'm running this step with has the permission to do a git push to this branch, which it does because I've set up this GitHub pat token, which has a fine-grained permission to push in this repo. It'll push it. And so if you go look at how this gets executed, there you go. Actually, I should go look at the pull requests. Let me go look at.
You're saying this is a trigger that goes off of other pipelines that kind of attaches to them and runs with them?
So it'll run on any pull requests, and you can see right here, this pull request got set up and it's running my Terraform docs automated action, and it actually committed files, like all these README files are files that the Terraform docs thing generates for me. Like I don't have to do that. Otherwise, I'd have to go to every single one of these folders and run Terraform docs in it, or I'd have to do a manual command. Like there's probably a recursive way to do it on my computer, right? But I don't want to have to do that, right? So using GitHub Actions and this, in this way allows me to kind of add that to my process, so I don't have to do it myself, which I like. But the reason why I brought this up was you were asking, like, well, is there a way to set up secrets or variables so that they can be used across repos? Because what I was showing you is like environments within a particular repo. And the answer to that is yes. So let's go look at, I want to show you where I'm referencing it. Y'all probably saw it, but I didn't highlight it. See this secret for Terraform docs pat token? So this is an organization that I plan on developing, a plethora of Terraform modules. And therefore, I don't want to set up Terraform docs for every gosh darn repo, right? So this secret, if you go to this repo, down here, there's no secrets, right? Now, but there is an organization secret, right? So there's multiple levels. There's an environment level, which one repo can have multiple environments. Then there's a repo level, which is like it spans the environments within the repo. And then the organization is like every repo within this organization has access to the secret. And you have to go set that up where you would expect in the, oh my gosh, where's my mouse? In the organization, under settings, same location, but it's just at the organizational level, right? And I can set up variables as well. So if there are certain prefixes that I want, in my organization, or I don't know, like a management group, or AWS org ID, or Google project, ID, whatever, like I can go set this up, and it's like, okay, like we're all going to go to this place, right? Good question.
I have one slightly related one. So with these triggers, do you always see that they're running, even if the trigger is, if the pipeline's coming from a different repo? Because you said you're able to set up a pipeline that you use across the organization for any pull request. It would then run this to add docs to what you're doing, correct? Or are you saying the pipeline was only for that project?
The workflow, the GitHub Actions workflow, they're technically called workflows, okay, but they are pipeline, in terms of the platonic idea of the thing, it is a pipeline, right? But it's called a workflow in GitHub Actions. But yeah, the workflow is that YAML file within the repo. So workflows are tied to the repo. You can, and this is an area I haven't delved too deep in, but you can reference actions from a workflow that are in different locations, which is kind of it's basically what you're doing when you reference one of the marketplace GitHub Actions.
You can just make a private marketplace essentially.
Through a GitHub repo, right? But you just have to have a really long whack name, for that action. But I don't know. Maybe there is a private, GitHub Actions repo within your organization. I don't have a GitHub Enterprise, and all the work I do at Microsoft is all in Azure DevOps internally. Because I'm not involved in open source projects or anything like that, but so I don't actually use GitHub Enterprise on a regular basis. But did anybody in here use GitHub Enterprise as their main gig?
Used to, but I didn't do anything fancy with it.
Yeah, me too. Yeah. So I can't. I don't know that. I'm sorry. Yeah. So let me trigger the front end. I probably should. It doesn't take that long to run. It's like a minute and a half. So there we go. And we go in here, we can see that those jobs get set up in, it's not the fanciest graphic, but you can see what's happening. You can step into the process and see the actions as they're executed. The build action, of course, does quite a few things. If I go look at the other one, right, there's probably, you can see all the things that get done. We're building, we're restoring, we're building, we're publishing into the binaries that we want to deploy. We're zipping them up, and we're uploading that as an artifact, so that it can be accessed from other locations within the pipeline, within the workflow.
Right.
What's that?
This is on the GitHub servers themselves, or you're pointing to a different environment?
So the artifacts are actually stored in GitHub, right? So you can see this artifact right here. That is my deployment package.
The execution of it, though, is also still happening in the GitHub.
Absolutely, yeah. This one is. I've implemented a Terraform module that sets up an Azure container app that acts as they're called GitHub runners. That's what they're called, as a custom GitHub runner. And that works pretty sweet. The only problem with using a container app, though, anybody want to take a guess what the problem is using a container app to run your GitHub Actions? Huh?
The Docker daemon.
Bingo. That's a bingo. You can't actually run Docker right within a Docker image. So if you want to build Docker images, you can't run container apps. But everything else, Terraform, Packer, any bash scripts you want to run, it's going to be super cheap to use container apps. So,
There's no action for building Docker images then?
There is, but like
In the other step, yeah.
it's like what if your host? It's like virtualizing in a virtualization.
So you probably have to first build it somewhere else or in the previous job and then use that. Right? That's how we do it in GitLab, and it's the same problem.
Yeah, and that's how I've set up, like my other repos where I'm building Docker images. Usually when you're building Docker images, like you don't have a lot of dependencies on other stuff anyway. So like you just need to build the image and then push it to your ACR, your ECR, or like what, I don't know what AWS calls them.
Or repository basically, or some.
Yeah, your container, JFrog.
Oh, yeah.
GitHub has one too, GHCR.
What's that?
GitHub has one GHCR. GitHub.
Oh, does GitHub?
Yeah.
Yeah, I think it's
That's weird.
right.
Yeah, they came out with like the package thing a while ago, and they've been adding stuff. But yeah, GHCR is in there now. And some.
I know some of that, like, part of it used to be, GitHub wouldn't do it, but I wonder now, are there still reasons to do any of that, like, to do any of that stuff outside of GitHub? Maybe even just cost. I don't know, if you have a big enough set of unit tests or something, would you not want to run it on a workflow? I mean, obviously there's like, what is it, a 1 hour timeout, but you're pretty much never going to hit that. Or are there still other reasons why you would pull things off of GitHub Actions?
Are you asking like where your GitHub Actions runner lives?
Yeah.
Like why you would not want to use a shared GitHub Actions runner?
Yeah, just kind of the generic ones provided by GitHub.
Oh, well,
Are there reasons not to?
they're usually like security related, right? Either network security or regulatory, right? Like I've seen places where they're like, the idea that the source code for the company would exit their network is like, mind-boggling, right?
But in that, I've seen that before, but I've only ever, when I've seen that happen, they switched over to Azure DevOps so they could run a local instance. If you're on GitHub at all, isn't it already leaving?
So GitHub, I don't know. I think so, like with GitHub Enterprise, yeah.
I think you can self-host GitHub Enterprise.
Maybe, yeah.
I did it at a previous company.
Oh, I didn't know you could self-host GitHub.
Good to know, yeah.
Yeah,
I believe it.
Enterprise, like, it's not a free thing, but
No, yeah. It's
Yeah. Yeah, me too. Like, I did not know that about GitHub Enterprise. Seems reasonable. And I may have inadvertently worked at a company where we did that, but I can't remember. But
I wonder if then you can run all of the Copilot stuff off that, because the Copilot with GitHub Enterprise lets you do stuff where like writes PRs for you and reviews them and stuff.
interesting.
It's really fancy.
have GPT write the code.
Devin, baby, put Devin to work.
10-person company, they're all just ChatGPT, writing the code, reviewing the code, business analyzing it.
Yeah. Yep. So I'm running my back end deploy here. This one I got 3 stages. I guess I structured it a bit differently than the last one, but maybe I had the Terraform built into the last step of the deploy. But this one I'm running the build to build the back end, and then I'm running Terraform, I think just to get the outputs, and then I call the deployment call to actually publish the Azure function. So if you go look at the code for the back end, like deploy the back end. And this is an example, but you'd probably have, like I'm doing a little bit of both the CI and the CD here. you'd probably have the build only execute on pull request. And then you would want to reference, the version of the artifact that you want to deploy in the CD. And so here you can see I'm similar procedure with the front end, but I'm using a different Azure CLI command to deploy a function app rather than to drop a zip onto a blob storage account. So it takes some additional parameters that I get from Terraform, which with the storage drop, I only needed the storage account name. That's it, because it's globally unique. But in this case, I need the resource group name where the function lives, and then the function name, and then I'm using a config zip, which is basically a command that says, hey, I want to deploy my Azure function using a zip file that has all the stuff in it. And then I just pass in the zip file that I acquired from this download artifacts command here previously. So basically, these things run kind of in parallel, but as you design them, you have to think about, okay, this first job is going to produce this thing, and where am I going to get that? Is that going to be an output, or is that going to be like an artifact that I need to pull from that place? And that's where you need to think about where these needs or dependency statements need to exist. So this one definitely needs something from the build because it needs that deployment.zip. And this one definitely needs Terraform because it needs the resource group name and the function name. Also, I wish there was a better way to do this, but look at this code that I'm using to output stuff. It sucks. I'm seeing some nods in the crowd here. It's really cumbersome, and like I probably made it more verbose than it needed to be, but this helps me identify where there's like an error, right?
Logging, because there's no logging in the GitHub action.
Yeah, and some of these are like secrets, so it's like you want to make sure like, okay, like I can see what's happening here, even if it goes ***, right? That there's a value there. So I echo the stuff, and then like this is actually going to echo it. This is just using bash to go grab it from Terraform and saving it to a local variable. Then I echo the local variable, and then here's where I'm actually saving it to a GitHub output. And I follow a naming convention so that I don't go cross-eyed. And basically, I use the same name as my input variable, as my local variable, as I do for my output variable. And then I dump it into GitHub output. And then you reference it down here using this crazy syntax, right? So you use $curly, and then you reference needs. And so that's basically saying, okay, I want to reference something outside of this job. Now where do I get it from? Well, the name of the job that I need it from is called Terraform. And that job name better be in your needs block here, if it's not your host. And then that job also better have a statement like this that outputs to GitHub output the exact case-sensitive variable name that you want. And it better also, actually, this is where it needs to go, right? You need to declare the output at the top of that job as well. So internally within a job, sorry, I'm not explaining this very well, but internally within a job, you reference it using this steps parameter, right? But if you want to expose that output variable outside of the job, you have to declare that output, and then you have to reference it using an internal token that points at the step within the job. Does that make sense?
It does.
It's very tricky.
Why? Then what's the benefit of breaking up multiple jobs? Especially when you have steps, so you can see what step it failed on, why you use so many jobs in the first place. And I've seen like sometimes you have to like technically you could just build an image and just push that image. You don't need to store it in container registry and download it, but like if you have it stored, you can use it in the future and stuff. But for something like this, it seems like you're just making the variable and then using it. Why go through outputting it and listening for it?
Usually it comes down to like the reusability of the thing or the efficiency of the thing, like the performance. Like, I actually don't know why I drew a dependency on build here.
Or it might have just been you were trying it out for fun to see how it works.
It could be, but I mean, in this case, like, I honestly don't know why I drew a dependency on build, but I could run build and Terraform in parallel, right? So if I can run two jobs in parallel, and then they come together at the last minute, then that could improve the runtime of my GitHub Actions, so that I'm not like waiting 5 minutes, or 10 minutes. I'm like getting it done in 3 minutes, right? So you have options, right, and flexibility to kind of design it however you want. So I would recommend definitely getting comfortable figuring out internal job dependencies as well as cross job dependencies, so that you can kind of slice and dice, and where you can run things in parallel, do so. Both from a performance standpoint, but it also looks really sick when the graphic gets displayed there. It's like, you show it to your boss and they're like, wow, you really coded something, didn't you? Wow, that looks really cool. Looks really complicated.
What you're saying is what is it? Wow, I'm forgetting the word. Employment insurance. You made such a mess.
Or it's just like, it's one of the laws of power, like make everything that you do like look easy or something like that.
One of the 48, yeah.
Is that Rule 48?
One of the 48.
Oh yeah. I don't know which one. It's one of the 48. Yeah, it's a great book.
Yeah.
48.
Second only yearbook, of course.
Huh?
Second only to yearbook, of course.
Absolutely not. Like, I think it's Robert Greene, right? All hail Robert Greene. Okay. 48 Laws of Power. Highly recommended. It's a great book. So any questions? I mean, I don't know why this one's stuck. Oh, it's queued.
Ran out of runners.
Yeah.
One of the reasons to not using GitHub Actions.
Oh, I just didn't know that there was a 1,200 minute a month cap. And I didn't know why things were not working. And I went around my whole division asking for help, and nobody knew what was going on. I'm like, wait, you didn't happen to hit your cap, did you?
Pay more.
Yeah, you just got to pay more.
Yeah, well, I spent a month that I was just working on like learning GitHub Actions stuff, so I hit my cap like halfway through the month. Switched to Azure DevOps, also has a cap. Hit that too, and then I learned how to run it locally, like use my computer as a local runner because I didn't want to get more minutes.
But I mean, it's pretty inexpensive, I think. I mean,
That was kind of where I was getting with my question. Where is it running? So there is some kind of fee. Is it,
Yeah,
but you get so much for free.
1,200 of the is the free amount.
yeah.
So minutes is the amount of time the build takes.
Yep.
Is this for like private repositories? Is that like if you have open source stuff, is it also like
I think
will be a cap, but it's probably higher, right?
free repos definitely. I think the free tier is like higher, but if you have private repos, you're going to hit your cap faster, unless you pay your tithe. But I've done a lot of stuff with Azure DevOps over the years. GitHub Actions are pretty cool. They feel a little bit lighter weight, a little bit more nimble than Azure DevOps pipelines. Definitely very much more like simple in the sense of it's just YAML. Like the YAML file is like the last word on things, whereas Azure DevOps there's like YAML, but then you instantiate the YAML as a pipeline. It's kind of interesting. It's kind of weird, but yeah.
Have you used Dependabot?
Dependabot?
Yeah.
I've not used Dependabot. but I see Dependabot show up on a lot of open source repos.
Yeah, I mean, that thing applies, it updates your dependencies. Like if you have like a nice workflow set up, then, tests and everything for you.
That sounds like a good talk for the next DevOps session.
The DevOps Meetup is also looking for talk.
Yeah.
I got GitHub Actions too, so it'll update your actions in your actions file.
Sounds like a good talk. I would come to this talk.
I have a Terraform question since you're here already.
Okay.
Does Terraform also provision resources inside a private cloud, like a company's own cloud that's not Azure, Google, or AWS?
If there's a provider for it, yeah.
Yeah, great provider.
Yeah.
Good talk.
There's a provider registry right here. So I think there's like a VMware.
Somebody say Proxmox?
I'm always wondering if we just have like pre-written bash scripts where you can just plug in a little bit of stuff and handle, like have already some of the stuff done for you.
So there's like a vSphere provider. So, I mean, maybe there's a Nutanix provider? Nutanix. Yeah, there's a Nutanix provider.